Okay, hopefully now you have done that assignment that you were supposed to do in between. If you haven't, go there right now. That is vitally important. It looks like this on the website. It says exploration at the top. We call it an assignment. Get it ready to be handed in, and we'll let you know later when and how it's going to be handed in. Don't worry about those details. So, this lesson presumes you've done that assignment, or at least done it enough that you get it. Little details, one specific question you're having trouble with, you'll be okay. You'll get through this assignment. Move this camera up out of the way. So, factoring polynomials, refining the procedure. By the end of the assignment, you might have a clue about how we might go about factoring polynomials. It may not be perfectly clear, but this lesson is designed to take the knowledge that you got from there and really refine the procedure. So what should you have learned from the assignment? For some polynomial p at x, if we can find a number k such that when we sub it in, we put that k in the polynomial, we get 0, we know some stuff. We will know that the remainder when we divide p at x by that x minus k will be 0. So for instance, if you sub in 5 and you get equals 0 here when you sub it in, we'll know that when we divide by x minus 5, the remainder will be 0. It's like prior knowledge before dividing. You know you're going to get remainder 0. Now that's very interesting, but the important implication is that means x minus k is a factor of p at x. So we'll have found a factor at that point. Now, at first glance, then it's like, well, is it just trial and error trying to get these factors? And the answer is yes and no. We can do a little bit better, and that's why this lesson is called Refining the Procedures. We can do a little better than just complete trial and error, but I won't tell you it's a lot better. But the nice thing that happens here is there's going to be a procedure. Okay. So, formally, what we've learned, the remainder theorem. When a polynomial p at x is divided by x minus k, the remainder is p at k. That is, you can just take this k value, whatever the number is, 2, 5, 7, just sub it in and you'll get the remainder. When we are dealing with fractions, that was the second part of the assignment. When there's a coefficient in front of the x, then you just sub in k over j. Really, you're subbing in the 0 of this factor, and then that will give you the remainder when you go to divide. And that was what the assignment asked you to do a bunch of times. It asked you to sub in this k and then do the division by x minus k, and you'd get the same thing. It asked you to sub in k over j and then do the division by j x minus k, and you got the same answer every time. And if you didn't get the same answer, that's a big hint in the assignment. It should come out the same every time, and if you didn't, well, you better go back and take a look because you've made a little error there. So, but the big deal for us, we don't really care about remainders except remainder 0. We care about if the remainder is 0, we'll know we found a factor. We'll know that x minus k is a factor or jx minus k is a factor. Now I know as I'm saying all those things, I can feel the letters running together, k's and j's and x's. That's the idea. You really have to see it in action once. So let me show you one fully done, and come back to this part of the video again and again if you're having trouble. It's very difficult the first time. I won't lie. It's very hard the first time when you see this thing. But the nice thing is it's very repetitive. It does the same thing over and over again. So if you, as you're doing your homework, the first one, oh, that was hard. Oh, the second one, oh, okay, maybe I sort of get that. The third one, you're like, oh, it's like that every time. And it's very repetitive. Here it is. Here's the procedure. To factor a polynomial p at x, find a k value such that p at k equals 0. Your mind might be flashing going, well, so I just try random stuff? No, I'll show you. You can do it a little bit. There can be a very systematic procedure here, and I'll show that in just a second. Once you find one that comes out to 0, you know that x minus k is a factor, so divide it out. Take that factor you found and divide it out to find the other factor. The remainder will work out to 0. Well, it says must here. It better. If you subbed it in and got 0 and then did the division and didn't get 0, you've made a mistake in one of the two steps. Repeat the process until you get all the factors down to degree 2. Factor any degree 2 factors using methods from grade 10 and 11, and the first example does something like that, so you'll get to see that in action. One little helpful thing about fractions, okay, we'll try whole numbers first, but if we run into a problem and we can't find a factor that's a whole number, there are some fractions that'll work, and I'll guide you to them. It won't just be random fractions. Where do the fractions come from? It'll always be in any polynomial that can be factored. The linear forms have the form x minus k. Those will be the whole numbers, or jx minus k. As a result, any zero of the polynomial will be p over q, where p is a factor of the constant term and q is a factor of the leading coefficient. What? Too many words there. I'll show you right off the top in the first example. I'll show you exactly what I'm referring to there. Here comes the first example. Okay, I want to get rid of this revealer because I've set this up so I can reveal a little bit differently for this one, and this will be in the way sometimes, so I'll just move it down there. Okay, you get handed this polynomial, and I went degree 4 instead of degree 3, and it says factor 2x to the power 4 minus 9x cubed minus x squared plus 18x plus 8. Here's a little hint. Instead of just being random numbers that we're going to sub in here, we are going to go let p at x equal 2x to the power 4 minus 9x cubed minus x squared plus 18x plus 8. Just like you did in the assignment, we'll say, okay, if this is the polynomial I got to factor, I'm going to give it a name, p at x equals. That way I can do my subbing and have a regimented procedure for subbing things in. Now, what I need to tell you is there's only certain numbers that'll work. Only numbers that divide into this coefficient, this last constant term will work. They're the only ones that have a chance at working. These numbers, as I sub it in here, better work out to negative 8 to get rid of positive 8. If they're going to do that, then these things must have been a multiple of 2 or 4 or 8. Something that divides into 8 is the only way it's going to work out. You don't have to understand that perfectly to start doing the procedure, but as you do the subbing, I think you'll start to see why it has to be true. So when I look at this, right off the hop, I don't have to try random numbers. I can look and go, oh, what divides into 8? And I've made a list of them over here for you. Here they come. Here is the numbers that will divide into 8. 1, negative 1. 2, negative 2, not 3. I can skip over 3. So when I said it doesn't have to be random numbers, yeah, it's not random. There's a very systematic thing we can do here where we go through these numbers, and we don't have to waste our times on things like 3s and 5s and 6s and 7s because they don't divide into this constant term here. So it saves you a little time. Is it a great move? Well, no, you still got a lot of things to try here, but it's a lot better than it was before. Now, the last part of the previous slide said there might be fractions, and those fractions are any of these numbers that I've listed here divided by anything that divides into this first coefficient. So the first coefficient is 2, so I take all of these numbers and divide them by 2, and that'll give me the fractions that I could use. Don't worry about the fractions until none of these work. Who wants to sub in a fraction if I don't have to? So I sub in, I divide them each by 2, 1 and negative 1 divided by 2, I got those. 2 and negative 2 divided by 2, oh, that's the same as these ones, that's 1 and negative 1. 4 and negative 4 divided by 2, oh, that's these ones. 8 and negative 8 divided by 2, oh, that's these ones. So, okay, so it didn't produce a lot of extra fractions here. And most of the homework questions don't. Like, there's maybe 1 or 2, I think, that have any kind of real fraction work involved here. But if you do have to look for that fraction, that's how you do it. You take these numbers that divide into 8 and divide them to anything that divides into this leading coefficient. Okay. So you can do what you want here as far as subbing these in. I go in this systematic order every time. I try 1, then I try negative 1. I try 2, then I try negative 2. Or I go 1, 2, 4, 8. I tried all the positive ones, whatever I feel like. Some of it might be based on your calculator, what's easiest to do, and I'll show you what I mean by that. So, okay, so first one I'm going to try. I'm going to try p at 1. And I wrote down the answer there. I'm going to show you how to get it. Bring up your calculator here, and you're going to sub in 1 to this thing. And what you really want to do is sub it in all the way across, type it all into a nice scrolling calculator, because if I've got to try something else, I don't want to have to retype all this stuff in. I'll show you what I mean by that. Okay, so I'm subbing in 1, and I've already wrote the answer there to be 18, but you'll see it come out to 18. 2 bracket 1, and I want to put that with exponent, so find your exponent button. My exponent button on this calculator looks like that. 2 times 1 to the 4th minus 9 times 1 cubed minus 1 squared plus 18 times 1 plus 8. When I type that all in, I get 18, as I had already written there in the slide there. P at 1 equals 18. What do I know at this point? I know that if I divide by x minus 1, I'll get remainder 18. Why is that important? Well, then it won't be a factor. I really need this to come out to be 0. So then try a different number. And the next one I tried here was negative 1. And why I like 1 and negative 1 is sometimes, on some calculators, it's easy to change all these 1s to negative 1s. You just go back over there where the 1 is and you hit the negative button and it moves over. Maybe your calculator doesn't move it over. If it doesn't move it over, if it overwrites it, maybe you would have liked to try 2 next, because you could just, wherever there's a 1, you could just overwrite it with a 2. But my calculator that I'm using here moves things over automatically. And you know what? If you've got backspace, insert, delete, these kind of buttons, get to know them on your calculator so that you can move these things around very easily. So anyways, if you've got a scrolling calculator like that, it's all on the screen there. I went back and easily changed all those 1s to negative 1s, and when I sub those all in, boom, I get the 0. And 0 makes us so happy in these questions, because now I know a couple of things, and I'm going to very carefully write out what I know about each of these things. The remainder will be 0 if we divide by x minus plus 1. That's what the assignment said. That whatever number I sub in here, whatever remainder I get, that will, or whatever number I get when I sub it in, that will be the same as the remainder when I divide by x plus 1. Has to change sign here. Okay? And that's very nice that the remainder will be 0, but that's not the really big deal. The really big deal is we've found a factor. X plus 1 is a factor, and we're well on our way to be able to factor this big polynomial that would have seemed impossible to factor a couple of weeks ago. So now that we've found a factor, we want to divide by x plus 1 to get that factor divided out. I'm going to do synthetic division because that's a little bit faster to do synthetic division. So if I'm doing synthetic division, if I'm dividing by x plus 1, my k value goes back to negative 1. I write down all those coefficients. 2, negative 9, negative 1, 18, and 8. And get that straight line down here. Let's find it. I got it here somewhere. Oh, there it is. Whoop. Draw a straight line in there, and then you bring the first coefficient down. Now here's a little mini lesson on synthetic division. If you've forgotten, you bring down the first coefficient. And then every time you come up from here to go above the line again, you multiply by the k value. So 2 times negative 1, that becomes negative 2. And then add. Because I reversed the sign, I'm adding with synthetic division. So negative 9 plus negative 2, negative 11. And every time I go above the line again, I'm multiplying by this k value. So negative 11 times negative 1. Now I get positive 11. And add to get 10. If this is confusing, go back and do some synthetic division homework, please. This procedure we're going to do again and again, so we really need it down pat. Okay, coming above the line, multiplying by negative 1 again. So 10 times negative 1, I get negative 10. And add. When I add those two things, I get 8. And then multiply by negative 1 again. Where is he? There he is. Negative 8. And when I add them together, 0. Very important. This procedure is self-checking. That is, if I got 0 up here, I better get 0 down there. That's what the assignment was all about, is it's predicting that remainder so I don't have to go through all that every single time. I can just know I'm going to get that remainder 0 that I want there. If you don't get 0 here, you've either made a mistake in your synthetic division. Maybe your k value choice is often the mistake. Sometimes people forget to change the sign there. Or you did your substitution wrong here, so you got to go back and check the substitution. That can happen too. All right, big moment. If you followed all that, you know how to factor any degree polynomial at this point, because I've pulled a factor off of this. Let me be clear about what we've accomplished here. I've got to find this thing here. Okay, I found it here. Here it is. So, our original p at x, which was the 2x to the power 4 minus 9x cubed, that whole thing, we've now found out that it has a factor of x plus 1, but it has another factor now, which I get from my synthetic division down here, 2x cubed minus 11x squared plus 10x plus 8. I've written all those coefficients up there. So things are a lot better. It was a lot of work, but I've pulled 1 degree off of this thing. Instead of it being a degree 4, now I've got a degree 3. Now, here's the good news in this procedure. It's completely wild. I get it. When you see it the first time, it's a wild procedure, but it's very repetitive. So now we do the same thing again. Instead, we should give it a new name. This new polynomial that I'm getting here, and I'm going to call it q at x instead of p at x this time, just to give it a different name so I don't get confused. It's going to be this polynomial part that I still have to factor, which is this part here, 2x cubed minus 11x squared plus 10x plus 8. And then I go again. I just go back to this list and start subbing in numbers. One little note, even though -1 worked once, it might work again, and that's when you get one of those double factors, one of those bounces. It won't often happen, but you better check. So every time you get to this, try -1 in there. And I tried -1, and when I subbed it in, I got -15. Punch that in your calculator so you verify that you get -15. So 1 and -1 are done. 1's not going to work again. If it didn't work the first time, it's not going to work this time. But if it does work once, it might work again. So I tried 2, and lo and behold, this one was a nice behaved polynomial because at q at 2, I got 0 again. Very important conclusions. When I subbed in 2 and got 0, I've got 2 important conclusions. 1, the remainder will be 0 if we divide by x minus 2. That's good. That is great news. But why is that so important? It's because it tells us that x minus 2 is a factor. And so I can take that factor and divide it out of this again. So here we go. Synthetic division again. A little faster this time. My k value here is positive 2. X minus 2 is a factor. That means my k value is positive 2. Write down all those coefficients. 2, -11, 10, and 8. Find my line here. Where is he? Oh, that's a little too low for the line. He's got to be up here somewhere. There he is. There he is. Here he comes. Okay, synthetic division procedure. Bring down the first coefficient. Multiply by the k value to come up here. And then add those two, -11 and 4. I get -7. Then multiply by the k value. This becomes -14. Add those two. I get -4. Multiply by the 2. I get -8. And when I add, there it is. So exciting. 0 as the remainder, as predicted. Again, it can happen that you don't get a 0 here. And if that happens, when you expected a 0 there, you got to check your synthetic division and check your substitution to see where you made the mistake. Because if those don't match up, something's wrong. So, after all that, what do I know? I'm going to resize that. Oh, I know this. I know my original p at x is made up of, I'm going to switch colors for my highlighting here because it's so exciting. I knew that x plus 1 was a factor, so there it is there, x plus 1. I found out that x minus 2 is a factor, so there's the other factor, x minus 2. And what's left now? A degree 2 polynomial. Where do those coefficients come from? Right here, 2x squared minus 7x minus 4. Now, that's how this procedure is going to work. If you start with a degree 4, you're going to have to do it once, twice to get it down to degree 2. If you start with a degree 3, you're only going to have to do it once. Start with a degree 5, you're going to have to do it 3 times. Now, we don't do too many degree 5s. There might be a couple in the homework just to show that we can do it. Usually we practice on degree 3 and degree 4. Because we could do this now any degree polynomial. You want to do a degree 80? Fine. You just have to do this 78 times. We won't really get hung up in that. We'll keep it under control. Now this thing here, warning folks, if you can't factor quadratics that have a coefficient out there, you better brush up on that. That's going to come up. That's going to come back and haunt you. The way I do them, personally, is I just look and go, what two things multiply to 2x squared, and what two things multiply to the -4, and try different combinations. I just sort of trial and error it. I find that pretty straightforward. But if you've got a procedure like decomposition, so if you want to look up that on the internet, you can look up decomposition. We need to be able to factor quadratics. It's a grade 10, 11 skill that we need ready to rock and roll. So, I finished off that factoring there. The factoring was two things that multiply to 2x squared would be 2x and x. two things that multiply to -4, and I just double check that this works. -4 times 2 is -8. 1 times x is 1. So you put those together, I get the -7. But again, you got to brush up on that. Well, exciting moment. Unbelievable that that assignment was enough to give you the weapons you needed to factor this thing. And this lesson's about regimenting that procedure. By the end of the assignment, you should have had a feel for what it would take to factor, but this is what the regimented procedure looks like. Very, very repetitive. Once you get it down pat, it should be good. That doesn't mean don't practice. You need this to be automatic. You will use this in the next chapter. You use this in calculus. It comes up all the time. So you need to have this practiced enough that it's entrenched in your memory. So, as you're doing homework on factoring, come back to this example because it's got all the steps in it. It shows everything that you have to do, and any degree should be able to handle with this. The only thing you'll have to watch out for is common factoring. That's a little nudge. When you're doing the homework, please, please, please watch out for a common factor before you start. Now, there are some other skills that came up, though, in the middle of that assignment. Not just factoring. There's two other things we can do now that we have that down pat. You can just determine if something is a factor without actually factoring it. See, this thing doesn't say factor. It says find out if 2x minus 5 is a factor. And if we want to know if 2x minus 5 is a factor, what we want to do is sub in the 0 of this thing, and the 0 of this thing is 5 halves. What we want to know is if I take 5 halves and sub it into this thing here, what do I get? And we'll talk about what the answer means in a second, but basically I'm going to use the remainder theorem and the factor theorem from the assignment and just use that to figure out if this is a factor. So I sub in 5 halves. P at 5 halves equals 2 times 5 halves cubed minus 5 times 5 halves squared minus 2 times 5 halves plus 5. But I jam that all in my calculator. And in this case, I got 0. Now type that in to make sure you get 0. You got to know your calculator and know how to type these things in. So you type that in, and I got 0 when I punch those things in. Very good. What does that tell us? It tells us that if I divide by 2x minus 5, my remainder will be 0. And if the remainder is going to be 0, 2x minus 5 is a factor. So that was sort of a side skill that came out of the assignment that wasn't exactly factoring per se, not the factoring procedure, not the long factoring procedure that was in this previous example here. It wasn't this whole thing, but it did come out of that procedure that we can just find out if something's a factor just by subbing in. It's a handy thing to do. Another thing that we can do that came out of the assignment is finding unknown coefficients. Now this kind of example comes up all the time later on. So I just need to tell you that these questions will frustrate you when there's unknown numbers in here like this. But we have to master them because it comes up in applications again and again. But let's talk about what we know. This time they said x minus 3 is a factor. Now if x minus 3 is a factor, we know something important. We know that if we take the number 3 and sub it in here, we'll get a very specific answer. When I sub in 3, I'll get whatever the remainder is going to be when I divide by x minus 3. Well, they told me it was a factor, so I know that remainder will be 0. I know I'm going to get a 0 out of this thing. So what I'm subbing in is 3, carefully putting the 3 in there. If x minus 3 is a factor, then f at 3 will be 0. So I sub in 3. F at 3 equals 2 times 3 cubed minus 3 squared plus k times 3 plus 36. At this moment in the question, this k causes you some panic because you're like, well, that doesn't help me find the k. Well, watch what happens next. Because we knew subbing in 3 will give an answer of 0 right over here. This whole thing, when I sub in 3, should come out to be 0 over there. So there, once that's 0 there, and if you're really with me, you go, oh, well, no problem. I can find k fairly easily now. This is more like a grade 9 question that has developed out of this. There's a lot of grade 12 big ideas coming here. Like this sentence here is a giant big idea of grade 12 math right there. But the math that comes out of it is not that bad. You sub in 3, and it's got to come out to 0, so I did some simplification here. 2 times 3 cubed is 54, 3 squared is 9. and then the 36 there at the end. I moved the 3k over here and collected up these numbers, divided by the -3, and got the k value there. So you just have to have a little faith when it seems like there's a k value here that seems like it's impossible to find, that this information over here is vital to what's going on there, and really go back to your assignment thinking and knowing that what number you sub in there is going to give you that remainder. Okay, that video lesson goes with factoring polynomials part 2. It is time to get your hard hat on, folks. It is time to get to work. I'm going to go back here and show you factoring polynomials part 1. By the time you go to the website, I'll fill these video lessons in here, a YouTube link that you can go to get to these video lessons. So that's what you'll see. But part 2 is right there, and that says this homework right there, and I will stick to this. This is the most important homework you've seen so far in this course. Practice is so important. Go to page 177 and go to war with this homework. You will have troubles in some questions because they ask you weird things, but some of them questions just ask you to do this procedure right there again and again and again, and the practice is important. So please, 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 as soon as I finish here, get your textbook out, page 177, and get to work. If you have any trouble, definitely contact me immediately, and I'll help you through it. But also check for solutions online to your textbook, because that will help when you make little mistakes, and contact friends and so on. And that was Wednesday's lesson. So we're back here Friday with a video lesson for the last part of this chapter. Actually, the chapter will be over. If you're wondering, oh boy, end of the chapter, what are we going to do now? Don't worry, I got it all planned out. Let me worry about all that stuff right now. You worry about page 177, work away on that stuff, and we'll talk more in the next video lesson on Friday. Okay? See you soon.